Hi, everyone, and welcome to Alpine Intel's Savvy Adjuster podcast, where we discuss the property loss topics important to adjusters with the experts who know them best. I'm your co host, Whitney Bowles. I'm a product marketing specialist with Alpine Intel, and I help our clients learn more about the benefits of choosing Alpine Intel for their claims assessment needs. Just a bit about Alpine Intel and what you'd expect from this podcast before we jump into today's topic, HVAC Systems 101. Alpine Intel is an industry leader in property assessment, dedicated to innovation across a broad range of property insurance intelligence. Through our operating brands, HVACI, StrikeCheck, and Donan, we're respected as the industry leader for our scale and track record of conducting expert, specialized, and accurate investigations. HVACI provides the leading HVAC and refrigeration system assessments and desktop pricing reviews for residential and commercial claims nationwide. StrikeCheck delivers comprehensive solutions for claims with electronics and other specialty electrical items through accurate on-site assessments, desktop pricing reviews, and lightning verification reports. Donan Engineering leverages the latest in technology and decades of experience to provide scientific insight into property losses with perils including wind, lightning, hail, flood, water, and more. We're always seeking new ways to help insurance professionals looking to learn a little something about the items involved in claims you're settling. You don't have to be an expert, but who doesn't feel more confident armed with a bit of knowledge? To that end, we have a robust adjuster resources page, which you can find linked in the show notes, as well as monthly webinars and the Savvy Adjuster newsletter. This podcast is an opportunity for adjusters to hear our very knowledgeable experts chat, compare notes, and share key points about a variety of property topics. Some of you listening might be familiar with us if you've submitted a claims assignment before, or maybe this podcast is your introduction to Alpine Intel. If you haven't already, be sure to check out our previous episode about wind damage to asphalt shingles. Either way, we're excited to share this episode with you. As I mentioned, today's episode is focused on a topic we get a lot of requests for, HVAC Systems 101. Just a quick disclaimer, we're going to be talking today in general engineering and insurance terms. Obviously, each property loss comes with its own set of circumstances, which is why it's so important to get an assessment to make sure you have the facts for your claims. Now let's meet our guests, Kurt Van Ness and Chris Molnar. Welcome to you both.
Thank you. Thank you very much.
So Kurt, can you tell me a little bit about your experience with HVAC systems?
Yes, thank you. Kurt Van Ness, originally from Indiana, and I began working as a contractor a long time ago, and eventually got hired as a forensic technician working for Donan Engineering, where I really got my forensic start. So as a HVAC contractor for so many years, working at power plants and smelter plants, working residential, commercial, hotels, restaurants. It was nice to be on the side of actually determining why something failed. In my everyday life as a contractor, I got to fix air conditioners, but now I got to do the true cause of loss determination. So, part of, knowing how to fix an air conditioner is one thing, but knowing how to explain how it fails is another. And that's where our expertise becomes so valuable. As technical director for HVACI, I'm responsible for all of our technicians out in the field, making sure they know exactly what to get, and also the final product that we produce, which is a paper that determines how an HVAC system failed, the recommendation, and also the price to get it back to its pre-loss condition.
And Chris, you're an experienced HVAC professional with experience in several different climate regions. Could you tell us a little bit about your experience?
Yes, I started off in my apprenticeship up in Massachusetts and Connecticut, so from the Northeast. Since then, I've moved to the Southwest. I have about 25 years experience in the field. I taught for 14 years running an HVAC program at a community college environment. And since then, I've worked my way up from a contract technician with HVACI, and I'm now a technical field manager.
Well, thank you so much for being here with us today. It sounds like we have the best of the best to discuss this topic, so let's jump in. So Chris, going back to the vast experience you've had in geographic zones, Can you tell us a little bit about how the different climate regions can affect HVAC equipment?
Yeah, every region has its own core components of systems. For example, up in the Northeast, we dealt very heavily with oil boilers, gas boilers. It's more of a heating environment. Air conditioning has always been sort of an add-on in that environment. Once we moved to the southeast, we went to more heat pumps. Very little bit of heating in terms of gas and oil, no oil basically, and we ended up with electric heat. So again, and then I'm going to turn it over to Kurt to talk about more of the central regions, but every region has its own core components.
Yeah, and to kind of jump off what he's saying, there are several system types and subtypes. Our main type is what we call a split system, which is your basic air conditioner paired with a furnace, which is probably about 75% of what most America has. And those zones can range from Florida all the way through Michigan with a traditional split system. Where it becomes different is when we're talking about heat pump systems, where there is no gas or there's no fuel, and a heat pump can only work into a certain zone. When it gets too cold, when it gets down below 0 in a certain zone, or even -10, the heat pump can't pull out heat from the air, and so it therefore becomes ineffective as a good heat source. So we'll see. My experience working in Indiana, from Evansville, I worked on geothermal systems, heat pumps all the time. So that little belt line going across the middle of the country is kind of a zone, a heat pump zone. Once we start getting into Indianapolis and Philadelphia, Pennsylvania, that's when the heat pumps really start to lose their effectiveness, and we start to see more gas fired. And as we get even more further north into Michigan and Wisconsin, we see a lot of boiler systems. The boiler systems are able to produce a lot of extra heat into the outside perimeter walls, and is a good source to keep your house from freezing. As we look onto the west and the south, we see, the southwest, we see a lot of evaporative coolers, and this is more of a dry climate down in Arizona, where we're actually using water to remove humidity from the systems, and it's a lot cheaper because we're just using a motor and some water to apply cooling. And then we look in the northwest, Seattle, where we might just have furnace only. And if you remember back a few years ago, and this is kind of one of our cases that we've discussed in the past, is that there are some zones that don't have air conditioning. And there was a change in the climate for a few months where it got into the 90s and even hundreds. And there are people out there that did not have air conditioning. So there are people that have to rethink sometimes their zone in a different, El Nino or other type of weather pattern event.
Is it possible that code upgrades, regulations, anything like that could affect, the equipment you need for your zone?
Yeah, I think that we have to realize that most codes do not play to repair. Codes mostly only play to replacement. So when we're dealing with zones and climate areas and stuff like that, the energy codes affect new system installations. There's nothing in EPA regulations or in building code that says you cannot repair an existing system. So the energy codes do change over time. We're about to go through another energy code change in 2025. That's going to phase out some refrigerants. But that does not mean that you cannot repair existing systems. So I think that all plays into a role.
Yeah, one of the examples of that, Chris, is when we see, a hail claim in Texas or wherever, and, they say that they have to have so many more inches of insulation on the roof, and that affects the curb height for the rooftop units. So if we're pulling off a rooftop unit now and it changes the curb, there's a chance that could actually change the recommendation and could fall into this code where replacements might might have an effect on the HVAC system. So, even some of the different counties that we deal with have different requirements, and we deal with those on a case-by-case basis that are brought to us.
Could we talk a little bit more about the refrigerant updates that you mentioned?
Sure. There's different classifications of refrigerants. R22 was around for years. I don't have the exact date in front of me, but it was eventually phased out because there's chlorine as a part of the R22 refrigerant. It was phased out for ozone depletion. The
I
EPA
remember from when I was a kid when that was a big issue.
Yeah. So what it was replaced with was a new series of refrigerants that includes a refrigerant called R410A. Okay, it was supposed to be a climate-friendly refrigerant. They are now in the process of phasing that out. The EPA recently published the guidelines for the eventual phase out of R410A to go to some more environmentally less global warming potential refrigerants. Starting in January of 2025, they will not be able to install new systems with R410A as a refrigerant. They're phasing that out and going to a combination of a bunch of different refrigerants. Carbon dioxide is one potential, and there's a whole range of butane and propane-based refrigerants that are already being used in some appliances. Now, all of this refrigerant requires additional training and some specialization of the technicians, as well as some additional tools, specifically with the carbon dioxide refrigerants, because they're very high pressures. I mean, we're talking pressures up to 1,500 PSI. With the propane-based refrigerants, there's obviously an explosion potential. So the care has to be taken working with those as well.
Yeah, and Chris, to kind of bounce off this, they're called A2L refrigerants, specifically R32 and R454B. These refrigerants, as he said, are mildly flammable or have some explosion potential, but there have been exhaustive tests by the manufacturers to make sure that the potential for that to actually occur is extremely unlikely, and those tests can be found online as well. The 2025 rollout is happening. There are some big manufacturers that have chosen R32, and we're expected to see product release in Q4 of 2024. So it's a really big year for HVAC systems and manufacturers. Whenever we bring and introduce a new refrigerant, there is a period of time where there are product testing that we don't know everything about the refrigerant, so there could be some volatility in the new products that are brought to us. We hope that the full testing has always been completed, but there are all different types of situations that the testing may not have accounted for, long line sets and loss of refrigerant and variables with the field and the field technicians that they may not have accounted for. We remember R410A is a very hygroscopic refrigerant, and one of the downfalls of that is when you were trying to do a repair or install a system during the rain or it was high humidity, we would get moisture into the oils, and over time it would cause acid contamination. Well, did we know that up front? And if we did, Chris, would we have rethought using R410A? So there are things that happens with different refrigerants that cause us, and especially in our business with forensic investigations, that we're going to see different types of failures that we may not have seen before.
Yeah, and when we start getting into refrigerants, the different refrigerants, as you mentioned, Kurt, but we have also the capability of people mixing refrigerants. Technicians get confused, and occasionally they might introduce the incorrect refrigerant into the system as well. And that's something that we do look for on the forensic side. is, are they actually using the correct refrigerant?
And on the positive note here, as R22s become less and less, it's gotten more expensive. R410A is going to follow that same path, but it's going to be many years. It's going to be 5 years. We got a 10%, 40%, and then 70% reduction in production of the refrigerant itself. So existing R410A systems can still be repaired. So that'll still be, a contractor's, reason for replacing equipment is because of the shift to, phase down R410A.
Okay, so if my my HVAC equipment goes bad, or I need to have it repaired, it's possible that even though I have the refrigerant that's being phased out, I don't necessarily need to replace the unit if it can be repaired.
That's correct. There's no EPA regulations or code requirements. As long as we can get the part, the refrigerant, and do the repair with what's available, no, you don't have to replace.
And the reason we
Okay.
say that is because there's only so much new equipment out there anyway. And if every time an HVAC system failed, we had to replace it with a new piece of equipment, well, we wouldn't have any new equipment to go around. So it is important in our industry that we are a repair first industry, and that if it can be repaired, if it's a small issue, even replacing compressors, that option is a viable option, and it still will be with R410A systems.
That's good. I think that make, do, and mend is becoming a real trend again. So it's good to hear that some industries still try to focus on repairing rather than, replacing any equipment that isn't working exactly the way you want it to. So I would any HVAC technician be able to look at residential and commercial equipment, or is there sort of a division there that insurance professionals need to know about?
Yeah, there's definitely in our industry, we have a sector of residential business lines and a commercial business line. When I was contracting, I did both. My company was a full suite of residential, commercial, and then industrial, which is a third subset, which is our power plants and aluminum plants, places that are extremely dangerous, that requires a real extended training. With that, there's two basic subsets for residential, and that includes what we call light commercial. So residential is anything from 2 ton to 5 ton, and then you like throw in churches or maybe a restaurant with no refrigeration, but some maybe even hotels where they have that basic equipment anyway, so they kind of fall into that category. It's whenever you get into the larger equipment, you get into the 15, 20, 25 ton rooftop units, where you get into the outdoor air, bringing in outside air, using that for free conditioning, economizers, and multi-stage compressors. It does get a little more complicated, and even more complicated than that is the refrigeration aspect of it. To guys like Chris and I, we see refrigeration equipment as basic equipment, but it can be scary to a residential only technician. And that's where there are the separations of contractors that they say, I only do residential, because that's what they focus on. But there are the majority of good contractors have a commercial business, because that is where a lot of the core of their business is in maintenance for commercial, and being able to keep your technicians going year round because of the extreme environments that they may be in. Chris, you want to piggyback off of the commercial and the refrigeration specific part of that?
Yeah, I think part of the commercial and an offshoot of the commercial that's also worth mentioning is that building control systems and building automation systems are becoming a big part of this. So there are a lot of commercial contractors out there that will actually take care of the core commercial, like the rooftop units and things like that. But they'll bring in a third party or another contractor that specializes in building automation systems. It's a slightly different side to the industry. You have to have very strong computer skills, and there's additional training involved with that. It's a very almost proprietary type of the business. On the commercial refrigeration, as Kurt mentioned, it's standard equipment, but a lot of technicians and a lot of contractors do have some issues with it because there's a whole list of refrigerants that are used in commercial refrigeration. Where for residential, we may have 3 basic refrigerants, R22, R4, 10A, and whatever's next on the list. With refrigeration, we might have 30 some refrigerants that we carry in our trucks. I know when I was doing commercial refrigeration, I had an entire rack of refrigerants in my truck because we came across so many. There's also ice machines. Ice machine is a food product, okay? And it takes a lot of time to service commercial refrigeration. I call it the hurry up and wait portion of the trade. You hurry up, do repair, you wait around for half an hour to make sure it worked. But yeah, there's a whole subset having to do with both of those, the control systems and the refrigeration.
And when we're talking about like building automation systems with HVAC equipment, are we talking about, thermostats and, really climate control, or are we sort of talking about something even more in depth?
It depends on the building. Okay, we start off when we talk about building control systems, we start off with the basics. Thermostats, some systems sense actual carbon dioxide in the air to make sure we're getting good air exchange. And then we talk about occupied, unoccupied for energy savings. And then most building automation systems now also include lighting control, and they can get very, very complex. Override, some now include access control, and it's all wrapped into the one system.
Yeah, and the whole, specialty part of the building automation is really the equipment itself. You have a master air handler and a chiller for, say a tower. And then within the building, you have these micro units called VAVs that will actually throw in additional heating or cooling to a space that may need it for its specific needs. So there's a lot of sensors, a lot of wiring, a lot of dampers, a lot of different types of ductwork, and you have the main system. So as a HVAC technician in the commercial field, it can be pretty overwhelming to inspect a big commercial system, especially like on a water loss when water travels through multiple floors. You're looking at ductwork, wiring, inspecting for individual damages. Those types of inspections can take quite a bit longer than a basic inspection. So it takes a technician with a lot of what we call patience and understanding, and even insureds and business owners have to understand that diagnosing some of these things takes time. And just because it doesn't work in one place doesn't mean that it's not failed just in that place. It could be a failure of the main control board or other things.
Well, we've talked about a lot of different types of HVAC equipment, but how can different kinds of weather affect them? Heat, wind, rain, lightning. What are some of the things you would expect to see from HVAC equipment that's been exposed to these kinds of conditions?
Yeah, I'll start with a quick story. My first day as an HVAC technician, my boss handed me a thing of wax and a rag. And I said, "What is this?" I'm not a car detailer. And he goes, "You're going to wax that air conditioner. When you're done cleaning it and checking the capacitor and checking the refrigerant, and you're going to spend an extra 10 to 15 minutes waxing that top and the sides, and you're going to get all the dirt off of it. And,
Was this
and I,
a Karate Kid type of thing?
yeah, it definitely was. I mean, I gained a lot of life lessons from that mentor. One of the things I learned was you keep your things nice and they don't rust. That's just
Yeah.
not with air conditioners. That's with other things as well. WD-40 is really great too. You don't use it on air conditioners, but you can use it on different things. Maintenance of the equipment is important, but the UV rays is a true thing. When I've seen so many units that have failed with rust from the top, where paint starts peeling and it actually will start degrading the motors. When I was working at the power plants, we would see advanced degradation due to what we would call acid rain. It's water molecules coming off the stack that's very acidic, and it will actually just eat the paint away. And so applying coatings, especially to coils and things like that, is very important. While that's not weather related, it's its own environment. And so we see advanced corrosion. We also see this with coastal corrosion, the same type. This air that has the salinity will actually eat away at the condenser coils. Same thing with irrigation water. And a lot of people don't think about this is when your irrigation is going, I know it's not weather related, but we're trying to keep our grass green. Water will actually hit your air conditioner, and depending on the alkalinity of the water will actually degrade the coating on your air conditioner and can cause it the fins to become brittle and eventually lose some of its lifespan. The big ones are wind, and then hail and hurricane related damages. We see some mitigation efforts with manufacturers that put hail guards on, and certain states like Florida say like every unit has to be bolted down. From a safety standpoint, we have to physically put hurricane straps on air conditioners so they don't go flying in the air when these events commonly happen. The other is wind related water and rising waters or from surge. So we have to think that as water gets up to a certain level, especially in homes with electrical control boards and things like that water can play a role in how these systems fail. Chris, you want to add on to anything that Mike said?
Yeah, I think I do. The only one that I think we missed talking about was lightning. And since I sort of live in the lightning capital of the world, it's worth mentioning. I mean, depending on locations of installations, lightning plays a big role. I mean, you can have a lightning strike 2 miles away, which causes a completely different type of damage than a lightning strike that happens on the property. So that's part of what we look at as well. There's really no mitigation for that. Mitigation for that is difficult. You can't predict where it's going to go.
Yeah, and the lightning high voltage surge could almost become its own podcast in itself because it's intricate, and how electricity flows, the effects of lightning on the electrical grid is important. When you see a transformer or at a substation blow and you see it 5 miles away light up the sky, and if you've never seen that, it's pretty traumatic. One time I was driving through Kansas City and there was a snowstorm, and we had thunder and lightning during the snowstorm in January, and a huge transformer blew somewhere, and it literally lit up the sky. It was a big purple dome. It was a pretty eerie thing, but I've seen that more than once. And the downstream effects of that is what causes a lot of the power surge issues that we see.
Is it possible for some people to sort of confuse lightning and high voltage surge damage?
The sources of damage caused by high voltage surge are many. A car running into a telephone pole can disrupt a transformer and mimic or show us some sort of electrical damage without any conditions that might provide another cause. Where lightning, when we see lightning, lightning will strike a power pole and cause that similar type of damage. Direct strikes are very rare. The arc marks are very rare. What we find is some direct strike damage is when lightning strikes a chimney or part of the house, it could actually catch the ductwork on fire. And that's probably one of the more common ones that we see is that type of external damage. It's not actually through the wiring itself. It's some sort of physical contact with a bolt and energy going through some of the metals within inside the house.
To add on that, I think I can come back. I can go add something to that because I have recently seen some damage that is direct lightning strike, and it's really not a direct lightning strike on the equipment sitting next to the house. But for example, I saw a piece of granite blown apart on the side of a house where it was, and then the energy from that strike actually went through the mesh that's behind the stucco of the house and distributed throughout the house. But there's usually some physical damage. There's a lot of energy there.
You mentioned arc marks. Could you kind of explain what that would look like?
Yeah, it's when two metal surfaces are close enough and there is electrical energy and it will literally jump across. We've seen this in some power line videos, specifically when we have an ice storm and ice is weighing down power lines and the power lines start to fall. As they fall, you can sometimes see static electricity going between the wires in some of those crazy videos that we see on YouTube. If you're ever interested, you can look those up. But we actually have what we call a contactor in an HVAC system, and we apply voltage to this starting component called the contactor. And every time we turn on an air conditioner, it provides this electromagnetism and it pulls in the switch. And if you've ever watched one of those, you can see it arc. And that's the type of arcing that we sometimes see when in a lightning strike where a line set is close to a gutter. And then that little section of distance, say it's an inch or 2 inch, will actually travel across one another. So metals try to go to like metals. So aluminum is going to go to copper, the path of least resistance. When it does that, it's going to leave a signature, and that signature is a burn mark. There have been lab studies. Chris and I have seen people try to mimic and mock it using various different devices, but a true arc mark caused by an act of God is very unique and usually leaves a melted pool with maybe a small signature of soot.
Okay.
Chris, how would you grade my description of that?
I think you're right on that. We don't see like large batches of soot, large burn marks. It's a very small, direct, there's no other way to describe it. Very little soot, lots of melted metal.
Would you sort of, if you're investigating wind or hail or any of that, would you also kind of look at the area surrounding the equipment to sort of help you figure out what might have happened?
Yes. One of the things we need to do is look around. Okay, if I'm on a roof and if there's no other damage around me and I have one piece of equipment that's damaged, the likelihood of it being wind is very low because there's no other damage. Yeah, I'm going to look at the surrounding area. I'm going to look at the surrounding equipment. I'm going to look at overall conditions. It's something we especially do when we talk about hurricane and straight line wind claims. Because, again, one area of damage, just a piece of equipment, is very rare.
And as a example, Hurricane Ian provided some challenges for all of us in that area where we had rising water and then we had rising river water. So we had not only had storm surge, but we also had rising river water. And then the lines became fairly important with being able to make recommendations. Chris, can you talk about your experiences working down there on Sanibel and some of the other islands and intercoastal ways?
Well, as you may have heard, Fort Myers Beach and Sanibel Island were almost completely destroyed during Hurricane Ian. Sanibel Island, I was actually the first HVACI tech on the island following the storm. One of the things that we had to do was take a look at the water lines. We had to actually go around and find the locations of where the rising water stopped from the storm surge and where the rain damage started. Because of the rising water, anything underwater was considered flood. Anything with just rain damage was considered hurricane-related damage. And then, of course, we had the wind damage tossed in on top of that. So if a unit was flipped over that was sitting on the ground, that was due to storm surge. If a unit was flipped over that was sitting on a roof, that became due to wind damage. But again, so we had to really look hard for the surrounding damage to see which category it fell into.
And to caveat, we don't know any of the policy language or anything like that. Our reports are based on the visual observations, and connecting the dots is usually done by the adjuster. They know where the water lines are. They know what our visual observations of how something fell over in a certain location.
And importantly, they're familiar with what their policies are going to cover.
Yeah,
That's
that is
correct.
You would have to stay more objective and sort of be less concerned with policy language, policy coverage, and all of that, because you're just there to see what you can see, determine the cause of the loss, and then report back to the insurance adjuster.
That's correct. The tech in the field doesn't know what the policy is. We don't have that information. We go out where we look at what the damage is and what caused it. That's our role.
Are there any other specific assessment experiences you'd like to cover? Any more fun stories or situations you've encountered?
I can probably talk about one that came into a really complex building automation type. I mean, I think that whole side of things has its own potential for its own podcast. But I mean, one of my favorites is going into a school that we went and looked at up in New Jersey area, and they've been having problems since their system was installed. So this was basically mechanical breakdown coverage claim, and we went through and evaluated the full system, the full automation system, and find out that it was improperly installed. They ran the wiring incorrectly, they ran piping incorrectly, and it took probably about 4 days to go through the complete system, from blueprints that we got in advance and actually go through the ceilings, trace out the wiring, and then come up to the conclusions and give the list of what had happened. Kurt, and you were on the back end of that one, so I don't know if you have anything to add there.
Yeah, it's interesting, on those claims, when HVAC first gets assigned a claim, the progression it could take. And in this case, we performed one inspection, wrote a report. It led to another inspection, and then potentially it went to litigation, and they were discussing whether they were going to sub-row against the installer. And it turns out they ended up not doing that. They didn't see the need to go that far. But we had the information, and in order for them to correct the situation was the most important part, because the school does not want to shut down. They operate 24/7, 365. It was one of those schools, and they just needed their stuff to work. And so we were able to provide them a solution that required them to go change the wiring, to get rid of the dips in the line set and some other control issues So that was more of a success story for us to be able to go in there and provide them exactly what they needed to get to pre-loss condition, without disrupting and disrupting the school business.
Well, I'm sure that the administrators, the teachers, and the kids all appreciated that you guys were able to help them correct the situation, because I can't imagine a whole school full of kids not having, good HVAC.
Yeah, a lot of times they'll push kids into different areas and they won't see a certain area for a period of time. So, we don't know exactly the thing. I wanted to share one experience, since we're in the heating season, to kind of change it up, the building automation, and now kind of a heating story. And this is a real life situation where someone's house caught on fire, and they went in and put a new roof on the house. And it turns out there was some decisions made about the venting of the furnace. A chimney was part of this house, and the furnace was using that to vent out the gases. A decision was made to abandon the chimney. Someone said, no, we don't need that anymore. They put the new roof on the house, and months later we got called out to investigate why the furnace wasn't operating properly, and we found that the chimney was capped in the attic, but they didn't consider that the furnace was still using that chimney. So we're very thankful no one was injured or anything in that case, but it just goes to show there had been a couple contractors that had been out there to inspect that didn't catch it. And while that may be concerning, it's important to note that our investigators are very thorough and caught that, and we're able to to turn off the furnace immediately and we condemned the situation. Obviously, we called the adjuster immediately and let them know of because obviously maybe the fire was covered and they have a contractor that replaced the roof, and then there was other decisions there. This is outside of HVAC at this point, that they would have to go back and figure out what to do.
Well, it sounds like that, again, those homeowners were in very good hands once HVACI arrived on site, because you guys are just impressively qualified. I think that is about all the time we have for this episode. Thanks again to both of you for being here with us, and thanks everyone for listening. Look for a mini episode recapping some of the most important points we covered here today and exploring 5 indicators of wear and tear on HVAC systems. Subscribe to this podcast to make sure you never miss an episode. And if you have any property claims that need assessments, head on over to alpineintel.com to submit an assignment or get more details about how our suite of services can bring you the answers you need to feel confident about your settlement decisions. You'll also find additional information resources in our show notes. We'll see you next time.